All right, so here we go. We're going to do a whole bunch of operations of functions. Addition, subtraction, multiplication, division with domain, and composition. So there's A, B, C, D, E, F. Three things we're going to do. So first of all, we're going to use f of x equals 2x plus 5 and g of x equals x squared minus 9 for our functions. So A is just f plus g of x. So that's how you could write it. And then you just add them. 2x plus 5 plus x squared minus 9. I'm going to combine like terms and just put them in the proper order. X squared first, 2x second, and 5 minus 9 is negative 4. Easy. B, subtracting them. So f of x minus g of x. That's the same as addition, except you have to subtract. However, you have to be very careful on subtraction, because when you're following a minus sign, like g is, make sure you're subtracting the entire g. So show it with parentheses. That way you should remember to distribute the negative to the x squared and then negative 9, so it becomes positive 9. And then do the same thing. Write your terms in order. Negative x squared plus 2x, and 5 plus 9 you can combine to be plus 14. So that's subtraction. C is multiplication. I guess we'll have room to do it right here. So we're going to go, let's do this. So now we're going to do C, which is f times g of x. So f of x times g of x. I think I have an extra parenthesis there, but it doesn't matter. 2x plus 5 times x squared minus 9. FOIL, or distribute. 2x times x squared is 2x cubed. 2x times a negative 9 is a negative 18x. 5 times x squared is 5x squared. And 5 times a negative 9 is a negative 45. Turns out there are no like terms here, it doesn't look like, so I'm just going to reorder my terms. Cube first, square next, and so on. And that is it. The next thing we're going to do is division while stating the domain. So f of x over g of x. So we're doing this part now. Is 2x plus 5 over x squared minus 9. So that definitely has domain issues because you're division by 0. So you have to figure out, when does x squared minus 9 equal 0? I'm just going to factor it like we usually do. It's not the only way to do this one, but it's a good way because it does guarantee you that you're going to find them all. X equals negative 3 and x equals 3. So since you can't divide by 0, and that would make the bottom 0, the domain of this new function here is x cannot be plus or minus 3. So next, we're going to work on the compositions E and F. So let's do E first because E comes before F. F of g of x. So the way it's written in that composite form here, I'm going to rewrite it to be f of g of x like this. So that's telling me I'm going to have to plug g into f. So g is x squared minus 9. You plug it into f, make sure you hit all the x's. This only has 1. So the x squared minus 9 goes in for this x. So we have 2 times the x squared minus 9. That replaced the x, and we still have plus 5. So distribute that 2, and now we have like terms, negative 18 plus 5, which is negative 13, and that is it. So that was E. Now we need to do F. F is G of F of negative 1. So you can do G of F of X first, like we did over here, but reverse it and then plug in negative 1. But what I like to do, I think it's easier, just use the number negative 1. So I'm going to rewrite this as G of F of negative 1. So now I have to find out what F of negative 1 is and just plug it in. Well, that's pretty easy because F of negative 1, according to this, is 2 times a negative 1. Oops. 2 times a negative 1 plus 5, which is just negative 2 plus 5, which is 3. So since f of negative 1 is 3, we can replace it with 3. So all we really have to do is g of 3. So now you just plug 3 in for g. G is x squared minus 9, so this would be 3 squared minus 9, or just 9 minus 9, and it turns out this is just 0. So that's how you do all the operations of functions, and I hope that helps.